Welcome to NSMO, the National Science and Mathematics Olympiad. In this lesson, we will study one of the most important periodic properties of elements, which is atomic radius, also known as atomic size. Understanding atomic radius helps us explain many trends in the periodic table and predict how atoms behave in a chemical reaction. Definition of atomic radius. The atomic radius is a measure of the size of an atom. It's commonly defined as the distance between the nucleus and the outermost electron shell in the atom. Because electrons do not have fixed positions and move in regions called orbitals, the atomic radius cannot be measured directly with a ruler. Instead, it is estimated based on how close atoms can approach each other. Another way to define atomic radius is the distance to which one atom can approach a neighboring atom. This distance depending on the type of bonding between the atoms. Of atomic radius. Because atoms bond in a different way, scientists use different definitions of atomic radius depending on the type of elements. Let's start with covalent radius. The covalent radius is used for elements that form covalent bonds, which are common among nonmetals. It is measured as half the distance between the nuclei of two identical atoms bonded together by a single covalent bond. Examples include hydrogen, the hydrogen molecule, and chlorine, the chlorine molecule. Second type of radius, metallic radius. Metallic radius is used for metallic elements. It is measured as half the distance between the nuclei of two adjacent atoms in a solid metallic crystal. Metals form a lattice structure in which atoms are closely packed together, allowing these measurements to be made reliably. In both cases, the covalent radius is obtained by dividing the bond lengths by 2. Metallic radius and covalent radius, the distance between the two nucleus divided by 2. Trend of atomic radius in the periodic table. Let us examine how atomic radius changes across the periodic table. We'll start across a period from left to right. As we move from left to right across a period, the atomic radius decreases. This happens because the number of principal energy levels remain the same. The effective nuclear charge increases. As more protons are added to the nucleus, the positive charge of the nucleus increases. The stronger attraction pulls the electrons closer to the nucleus, causing the atomic radius to decrease. Now let's move to down a group from top to bottom. As we move from top to bottom in a group, the atomic radius increases. This is because the number of principal energy levels increases. Each new energy level places the outer electrons farther from the nucleus. Even though the nuclear charge increases, the effect of additional energy levels and shielding causes the atomic size increases. Size of ion compared to neutral atoms. Atoms can lose or gain electrons to form ions, and this affects their size. We start with the positive ion cations. Positive ion or cations are smaller than their neutral atom. This occurs because electrons are lost, electron-electron repulsion decreases, the remaining electrons are attracted more strongly to the nucleus. As a result, the electron cloud contracts, making the ion smaller. For the second type of ions, negative ion, anions, negative ions or anions are larger than their neutral atoms. This happens because extra electrons are added, electron-electron repulsion increases, the outer electron shell expands. Therefore, the ionic radius becomes larger than the atomic radius. The more principal energy level occupied by electron in an ion is larger than the ionic size. For example, the size of a positive ion increases from top to bottom. This is because additional energy levels are added as we move down the group. Factors affecting the size of an ion. There are three main factors that affect the size of an ion. First, number of energy levels. The number of occupied energy levels directly affects ionic size. More energy level mean electrons are farther from the nucleus, resulting in a larger ion. Number two, effective nuclear charge. The effective nuclear charge is the net positive charge felt by the outer electrons after accounting for the shielding effect of inner electrons. For cations, loss of electron increases effective nuclear charge, ionic size decreases. For anions, additional of electron reduce the effective nuclear charge felt by each electron, ionic size increases. Other factor. Number three, electron-electron repulsion. When electrons are added to the outermost shell, as in anions, repulsion between electrons increases, the electron cloud expands, ionic size increases. Exercise atomic size in the same period. Now let us solve the exercise. We are asked which of the following elements has the largest atomic size given that they are all in the same period: aluminium, magnesium, sodium, chlorine, and silicon. All of these elements are in period 3. Across a period, atomic size decreases from left to right. So, we arrange them from the largest to smallest atomic radius. We get sodium is the largest, 1, followed by magnesium, aluminium, silicon, and the last one is chlorine. Therefore, the element with the largest atomic size is sodium. We can conclude our study for today. Atomic radius is the fundamental periodic property that helps explain trends in the periodic table. Across a period, atomic size decreases due to increasing effective nuclear charge. Down a group, atomic size increases due to addition of energy levels. Ions differ in size from their neutral atoms depending on whether electrons are lost or gained. Understanding atomic radius allows us to better predict chemical behavior and periodic trends. Thank you, and with my best wishes for success at NSMO.